Hi, and welcome to A Lack of Self-Isolation.
We've all been self-isolating a lot, and we thought it'd be kind of fun to have a talk about how containers sometimes don't self-isolate themselves, even though containers are supposed to be the things that isolate, like we are. And so that's how this talk came to have that name.
But first, let's introduce ourselves.
So I'm Justin Cormack. I'm an engineer at Docker. Been there for like nearly 5 years now. I work on security, open source, and all the bits of Docker that you love.
And my name's Liz Rice. I look after open source engineering at Aqua Security.
And we've done a talk at DockerCon before together back in the days when it was in person, and it was good fun. So we thought we'd do one again.
Absolutely. And the talk we originally proposed was that we were going to explain a new vulnerability, talk about how to exploit it and how to remediate it. But let's just have a quick word about responsible disclosure.
Because that CV has not been published yet, and so we're not going to talk about it at all. But so we kind of had to change the talk a bit, but hey.
So when somebody finds a security issue in Docker or Kubernetes or basically any product, if they're responsible, they'll get in touch with the security team for that product, discuss it with the product team, and they'll agree a disclosure date. That gives the product developers time to create a fix for the security issue so that at the point where the issue gets disclosed to the public, there's a fix that users can upgrade to, and it means there isn't a window where attackers know about the vulnerability and can exploit it, but users don't have anything that they can do to remediate it. So that's responsible disclosure.
If you find a security issue with Docker, just mail security@docker.com. I'll get that email, as among other people, and we'll enjoy fixing your exciting security problems. And you'll be helping all the users of the product. And if you're not sure about who to report an issue to because it's in some complicated part of the stack, you can always mail us and we can help direct you to the right place as well.
So we couldn't talk about a hypothetical issue that might hypothetically be published in a few days. So we decided we would talk about something that is in the public domain. We're going to talk about some issues related to CapNet Raw. Now, strictly speaking, this isn't a vulnerability because, as you'll see, it's kind of working as designed. But there are ways to exploit this capability and things that you can do to prevent people from being able to exploit it. And that's what we're going to talk about today. If we're going to talk about capabilities, I just want to level set about what these Linux capabilities are. So back in the day, you were either root and you had privileges to do everything, or you were non-root and you didn't have any of these special privileges. Then capabilities were introduced to give us finer grain control over the permissions that you can assign. So taking a few example capabilities just to illustrate, CapNet bind service lets you bind to low numbered ports. And the reason for this is you don't, on a shared machine, want one user binding to, let's say, port 80, the well-known port for web traffic, because it would prevent any other user from binding to that port. And you want to make sure that only people who are supposed to do that can do it.
Or the SSH service. You definitely don't want someone else running your SSH service for you.
That is very true. Another example of a capability is capsys boot, because you really don't want just anybody rebooting the machine willy-nilly as they choose, particularly if you're on a shared machine. And this is a really good example of a capability that really doesn't have any business being granted to applications that run in containers, because why would you want an application to be able to reboot the machine?
If you actually try and reboot a machine in a container, it actually the Linux actually kills your container instead of rebooting, because it thinks that's a much more sensible thing to do.
And it really is. And then here's the capability that we're going to concentrate on today, which is CapNet Raw. And this capability allows you to open raw network sockets. So in a normal network socket, you only get access to the data part of each network packet. With a raw network packet, you also get to manipulate the headers as well. And that means you can implement any network protocol you like in your user space application. And an example of a protocol you might choose to implement would be ARP, Address Resolution Protocol. So ARP is used to determine which MAC address corresponds to an IP address. If you can build ARP packets, you could incorrectly respond to requests and pretend that you're the MAC address associated with a particular IP address, even when that's not true. Doing that is called spoofing. So if I know which IP address is supposed to receive DNS requests, I can use ARP spoofing to pretend that I am actually that DNS service. And then when an app makes a DNS request for a particular URL, I can respond with incorrect information about that URL, which means that traffic intended for that URL gets redirected to wherever I choose to send it. That sounds pretty bad. Let's see it happening in Kubernetes. Okay, so in this demo, I have 2 pods running in my cluster. One of them is fake, and it has the IP address 10.32.03. We're going to need that later. And the fake pod is listening on port 80, and when it receives a request on that port, it's going to respond with the word hello. I also have a victim pod, and this is my normal, perfectly well-behaved app, but we're going to fool this app. So I'm going to start by just opening a shell into the victim pod, and from there I'm issuing a curl request to example.com, just to show that we can get traffic as normal. We get the response as we'd expect from example.com. So everything is behaving perfectly as expected at the moment. Now I'm going to start a third pod called Hacker, and this is what's going to run the exploit and do the ARP and DNS spoofing. And in the bottom window, I'm going to run an application called Tracy, which lets you trace out different events and syscalls. In this example, I'm going to trace out CAP-capable events. CAP-capable happens when an application is checking for whether it has a particular capability or not. So when I start my hacker pod, my Tracy is listening for events from a new container, and it's starting tracing out these events. You can see all these CAP sysadmin events being generated from that pod. So now I'm execing into the hacker pod, and I'm going to edit a hosts file, and I'm going to say, let's say that example.com is at the IP address that actually corresponds to the fake pod that we saw earlier. So now I've set that up, I can run the exploit, and this is where the spoofing takes place. And once that's got started, you can see the CapNet Raw events in the bottom pane of this window. That's where the exploit needs CapNet Raw in order to send those ARP packets. Now if I go into the victim pod and issue the same curl request to example.com, this takes a little while because Kubernetes is checking for all the possible different variations of example.com, how that could be interpreted as a local address in the cluster. But eventually it will try to resolve to example.com, and my spoof DNS service gives back the address of the fake pod. So that's where the curl request gets directed to. The fake pod receives that request, responds with the text hello, and that is what we see the victim, that's the response that the victim sees. So we've been able to intercept traffic from that victim pod and respond with any content of our choice. And you might think that's pretty bad. And I didn't even have to do anything special to grant my hacker container the ability to do that. If you start a container, you can use a utility called captch to check the current set of capabilities. You start a new container, you'll see that by default, CapNet Raw is one of the capabilities that gets granted. And given that we've seen how dangerous that could be, it does beg the question, why is that part of the set that's granted by default?
Indeed.
Let's ask someone who knows.
It does seem, I mean, when this issue was reported, and there's been a few other issues like this, it's like, well, why can't we just turn this off? And well, it turns out that the reason that we actually granted this in the first place was that there's a program that everyone likes to use that needs CapNet Raw, and they want to use it for debugging. And that program is ping. If you tell users, well, in a container, you can't debug your network with ping, you can't run ping, ping won't work, people are going to be really unhappy, because network problems are, kind of things that we all have to deal with. And container networking is not the most obvious thing that always works for everyone all the time. It's something that people have issues with, and things are weirdly set up and things don't work, and you can't get from one container to another, and you want to find out why. And first thing you want to know is, well, have I got a network? Is the local cable plugged in? And so if we just said, well, no, ping doesn't work in containers, they would be really unhappy. The whole point of containers was that they would just work like normal computers. And so when Docker basically created that, we were like, well, we have to give CapNet Raw because of ping. So is there any kind of solution to that? Well, it turns out actually there is. There's this thing called ping sockets. So 10 years ago, in 2010, the developers of OpenWall, which is this kind of cool security-focused, security-enhanced Linux distro, decided they didn't want any privileged binaries. They didn't want any SUID root. They didn't want any special capabilities on binaries. They wanted everything to just work. And they managed to fix all the things about it, except for ping. Ping required basically the CapNet Raw privilege, which normal non-root users in Linux just don't have. And so they basically said, well, let's fix this in Linux. Let's fix the kernel. This is annoying. So they created a new kind of socket called ICMP socket, but usually called a ping socket if you look it up. And that lets you create ICMP packets, but not any protocol, not like CapNet Raw. It behaves a bit like CapNet Raw, but if you try and do anything except ICMP, it won't let you. In fact, specifically, it won't let you do anything except ICMP echo packets, which is the actual ping packet. If you try and do anything except that, it won't work. But any user can use this in their patch. So it's like, well, quite exciting. So like users can do ping, but users can't do raw sockets. That seems like a great idea. But when the Linux kernel developers got this patch, they looked at it and said, well, I don't know, what if this is insecure? What if there's a problem about this? I mean, we've never allowed this before, so why change it? So they decided to make it so that you have to turn ping sockets on by default. Like root users can use them because they could anyway. But if you want other users, you have to set this group range sysctl, which is the control where you set up network parameters. And in the example below, 02147483647, that's all groups because it's the 32-bit signed number for groups. It's set by group, not user ID. And although it's called IPv4, it applies to IPv6 ping packets as well. It's like confusing.
Of course it does.
But also, it's part of the network config. And network config is different in each network namespace, which means that every time you create a container, you have to set the sysctl, which is kind of annoying. And also, it's quite a lot of typing. But if you do that, you can set the sysctl, and you can drop CapNet Raw, and we should be able to use ping sockets, and maybe we can do ping. Let's try it out. So I'm going to run a Ubuntu 2004 container with that sysctl, and Ubuntu actually doesn't have ping installed in the base container image anymore. So we're going to install inetutils ping. We'll come back to that in a second because it actually turns out there's two pings that you can install on Ubuntu, but inetutils ping is one of them. So we'll install that, and we'll look at the ping binary, user bin ping. If we could type that, user bin ping, and we can see that's got a little S and it's in red, which means it's SUID root, which is we'll talk about in a second. But if we do ping localhost, yay, it works. We can take the SUID root flag off this, and interestingly enough, it still works because SUID doesn't really do anything in containers because you don't gain any more capabilities than you had before from containers if you're already root in the container. Let's try the other ping. This is actually the default ping that a normal Ubuntu distro has installed if you have the full install. We'll look at this one, and you'll see it's green, does not SUID root, this one, and we try and ping. Oh, we can't ping. So this is what confused me the first time when I was running this. Like, oh, well, ping sockets, maybe they don't work. What are we going to do? So let's see what's going on. Let's install strace and see what's blocking us. Is it trying to open a raw socket, or what is it trying to do? Let's have a look. Well, maybe it's trying to use a raw socket. Oh, it's not trying to use a raw socket. That's not what's being blocked. We can't execute the binary at all. Now that's really kind of weird. Why can't we actually execute the binary? So what we need to look at is actually the file system capabilities on this binary. If we do use the getcap program, it says it's got capnet raw. It requires capnet raw. It's got capnet raw set as a file system capability. So we're going to remove that, and then we're going to try pinging again, and yay, it works without that capability. So basically, the file system capability, it says it needs capnet raw. It doesn't actually need capnet raw because we took it off. It still works because we've set everything up correctly, so it doesn't. But annoyingly, it's blocking us doing it, which is kind of a bit frustrating. But if we look at the strace now, it's working, and we can see it's got IP proto IP. That's the ping socket. So that's actually not the ping socket. I've really pointed the wrong one in my recording of this. And so let's try running this in CentOS. CentOS actually comes with ping installed by default in the base image, which is useful. And we use ping in CentOS. Ping in CentOS, ooh, it just works. That's really nice. It's also got getcap installed, which is kind of nice. So we look at the ping binary, and we see it's actually got capnet raw and capnet admin, but it's only got plus P and not plus EP. Plus P says it's permitted to get those capabilities, but it's not required to with the E flag. If we set EP like in Ubuntu, we're adding capnet admin as well, which actually doesn't need. But then, as you see, it behaves exactly the same way as Ubuntu. So the plus P flag is actually a way better configuration. It gives it that capability if it can get it, but it doesn't block it if it can't get it. And as it works without it, the setup's way better in CentOS than Ubuntu. And I think, that looks like a way more sensible setup for it to be like that, because then it'll work even if you don't have capnet raw, but you can get it, then it'll still work. If you don't have the sysctl set, for example, it'll work if you can get capnet raw. So that's really, so it's actually really complicated. It took me a while to go through all the combinations of distros. Like if you look, Alpine doesn't have any file system capabilities or SUID or anything. It just works. And actually it has done for many years. It's like it used to be the only one I used to demo ping sockets in containers in, is like just works from like a couple of years. Ubuntu 18.04 doesn't set the file system capabilities, does set SUID. So in fact, it's now works. So there's a weird kind of mix of different things. But say we want to actually fix this. Say we want to get rid of capnet raw because we really want to make containers more secure in the long run. So let's try, if we want to get rid of capnet raw, the first thing we want to do is set the sysctl by default in all containers we create. So I'm going to open a patch for DockerCon in Docker to do that, and probably we'll set that in containerd and things, but we'll have to look at all the different platforms like Kubernetes and things to get that. While we're doing it as well, there's this whole unprivileged ports that Liz mentioned before. Like it's actually okay to run port 80 or port 22 in a container, because it's not the host. It's actually okay for an unprivileged user to run SSH in the host. It's not going to, in the container, not the host. So it's actually, you can basically turn off the privileged ports facility in this as well. And so in container, it makes sense to turn that off. That's also an IP config. So at the same time, we'll do both of those. Turn those things off, set those syscuttles by default for all containers unless you actually override them, because I think that's always safe. There haven't been any security issues in ping containers in Linux in the decade since it's been available. So I don't actually think it's exploitable. Ping as an unprivileged user is just a good thing to have. It's really useful. And this won't break anything, and you can always override it if you really want. Then the setup that Ubuntu's got with the default ping is actually still really annoying. It requires EE. So it requires that capability to be set. And if you don't allow that capability, then it fails to run the binary at all, even though the binary works perfectly well without that. So I think that we need to file a bug report on Ubuntu and say, be more like the CentOS setup, just use P. Doesn't really make a lot of sense to have this, because basically your binary works perfectly well without this in almost every reasonable situation that any user would ever use it in. Probably every situation, and see what they say. And then once we go through all the other distros as well, because there's obviously other distros that need to check everything in them, but then potentially we can just turn CapNet Raw off by default, so that you then have to add it if you explicitly want it. If you're trying to do something weird, if you want to do ARP spoofing because you're testing something, if you want to do other raw sockets because you're implementing your own protocol, great, turn it on, because then you're saying explicitly, I want this capability to do weird things. But if it's just, I want to debug ping with ping, then let's have that by default, and not let people exploit these things by default. Because like the thing that showed, it was not filed as a CVA, wasn't accepted as a bug because it was intended, but it's really unexpected. It's not the kind of self-isolation that we're looking for in these times of self-isolation.
So work is now afoot to improve the defaults and make containers more secure by default, but that work is going to take some amount of time. So in the meantime, what can you do to run your containers more securely? Our advice is drop all the capabilities that you possibly can.
It's almost certainly the case when you're running any sane containerized application. You don't need any capabilities at all. Most applications run fine if you do cap drop all. It's actually fine. Just try running a container like that. Obviously, in the short term, you might have you will have the issue with ping, but I've told you how to set the syscuttles so that ping actually works. It's a little bit fiddly if you're using the wrong Ubuntu ping and you have to remove the capabilities, but you can make ping work if you want, or you can add those things, or you could. But generally, I found very, very few applications actually need any of the capabilities. We know that some applications need some of them for build. There's some weirdnesses about that. So when you're building containers, you might need a few more capabilities. Some Linux distros need to install devices and things like that. So it's kind of, there are some little sort of nuances with build, but at runtime, you can almost certainly just try dropping all the capabilities on your containers. Don't run them as root, run them as an unprivileged user. And that you'll probably find it works. So that will solve the problem in the short term.
And if you really want to check exactly which capabilities your applications are using, if you want to, you can use that Tracy tool that I showed earlier, and you can look at the cap capable events to see which capabilities it's actually looking for. But as Justin said, the chances are it doesn't really need, for most applications, most circumstances, just try dropping all the capabilities and see whether it works.
But do have fun if you want to work on some exploits, or see how things work, or see how all the fun things you can do with raw sockets. Then just add capabilities as you need them.
So thank you very much for attending our session about a lack of self-isolation.
We'll be in the chat. We had fun. We're happy to answer all the questions about capabilities and raw sockets and ping sockets, and how to fix your applications if they don't work, if you drop capabilities and all those things, and how to debug
those
them.
Questions.